Lesson 5-4, solving absolute value inequalities. So an absolute value inequality is an inequality that actually has an absolute value in it. And so just like our last lesson dealing with compound inequalities, we're going to do the same thing. There's going to be two cases though when we have absolute value inequality. So what are those two cases? Case one, you're expressing the inside of the absolute value symbols as non-negative. So if x is a non-negative, then the absolute value of x is going to be x, positive x. Case two would be the expression inside the absolute value of the symbols is negative. So you're going to solve it where x is negative, and the absolute value of x is going to be a negative x in there. Just keep in mind that absolute value just means the distance from zero, and the distance is always positive. So what we want to find out is what are all the possible values of x we can have that will make the statement true. So example 1, solve the absolute value of m plus 5 is less than 3, and then graph the solution. So part A, rewrite that for case 1 and case 2. So the first thing I would do is just write it m plus 5 is less than 3. So what they give you, that's case 1. Case 2 would be m plus 5, and then it's going to be not less than 3, but it's going to be greater than negative 3. So one way I think about it is when I'm putting a negative in there, I just flip the symbol, because when you multiply and divide by a negative number, you always flip the symbol. So now I can just solve for m. So I'm going to subtract 5 here, and I would have m is less than negative 2. And over here, I would subtract 5 on both sides, and I would have m is greater than negative 8. And then I'm going to use the word and here, or you could just rewrite this. If we put it in set builder notation, we could put it as this, m such that m is less than negative 2, but greater than negative 8. Or you can write it this way, where you have m is less than negative 2, but greater than negative 8. Either way would be correct. Now to graph it on a number line, we would have to go all the way to negative 8 and up to negative 2. So I'm going to go negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2. Since it cannot equal either of those numbers, I'm going to have open circles on negative 8 and negative 2, and it has to be in between the two. That would work. And just to verify that that would be correct, I pick a number that's in between the two. So maybe I use 5 or negative 5. So if I put negative 5 in for m, negative 5 plus 5 is 0. The absolute value of 0 is 0. 0 is less than 3. If I chose a number bigger than negative 2, let's say I chose 1. I put 1 in there, 1 plus 5 is 6. The absolute value of 6 is 6. 6 is not less than 3. So I know it has to be in between here, and my graph is correct. Next, solve this one. When I take it out, I take out the absolute value of m minus 7 is less than 7. And here I'm going to do it another way. When it's less than, I'm going to put the m minus 7 in the middle. I know it's less than 7, but it's going to be greater than negative 7. Then I can just add 7 to both sides, and I would have m is less than 14, but greater than 0. Now this is just one way of doing that. If I did it separately, I would have m minus 7 is less than 7, and I would add 7 to both sides. Here's your m is less than 14. And then I would also have m minus 7 is greater than negative 7. Add 7 to both sides, and there's your m is greater than 0, which is what I have here. You just need more space to do that method. So I typically write this way when it's less than. If it was greater than, then I would have to do a little bit different. Now to graph it, and you go from 0 to 14. So I'll do 0, and then I'm going to come by 2. So 2, 4, 6, 8, 10, 12, 14. I have open circles on 0, open circle on 14, and it's in between the two, so I attach them. Next example, solve this one. So this one's all less than. So when I take it out, I have 6m plus 12 is less than 12. It's also greater than negative 12. I'm going to subtract 12 on all three parts. And now I have negative 24 is less than 6m, which is less than 0. Then finally, I'm going to divide everything by 6. And I'm left with negative 4 is less than m, which is less than 0. And on a number line, I have negative 4, negative 3, negative 2, negative 1, and 0. We have open circles on negative 4 and 0, and we attach them because it has to be greater than negative 4, but less than 0. Example 2, these are ones where there is no solution. And we're going to see why it's no solution. So if I analyze the problem right here, absolute value of n minus 1 is less than negative 5. When the absolute value is by itself, it has to be a positive number. If it's not, because anything that comes out of the absolute value is always positive. So if I were to, let's just say I tried solving this and did it the way I was doing before. So it would be less than negative 5, but greater than positive 5. If I were to solve by adding 1 to both sides, I would now have, this would be negative 4, and this would be 6. If it's less than negative 4, but greater than 6, there's nothing in common with those. So let's just say I chose a number that's greater than 6. So if I choose 7 in here, which is bigger than 6, 7 minus 1 is 6. Absolute value of 6 is 6. 6 is not less than negative 5. So I know that this cannot work. If I choose a number that's less than negative 4, so let's choose negative 5. If I put negative 5 in here, negative 5 minus 1 is negative 6. The absolute value of negative 6 is 6. 6 is not less than negative 5, so that one doesn't work. That's why it's no solution. So the quicker way is just recognize that when the absolute value is by itself, it cannot be less than a negative number. Absolute value has to be, must be greater than or equal to 0. Next, here again, I have the absolute value by itself, and it's less than a negative number. It means there is no solution here. And then when it does say that, then graph the solution set, since there is no solution, there is nothing to graph. Therefore, we do not have a graph on it. Example 3, use absolute value inequalities. So word file format. This is a software developer who wants to determine whether the changes he made to his program are popular with users. He releases a survey to get some feedback and finds that 72% of users like the changes. The margin of error is within 1.8%, which means that within a reasonable level of certainty, the actual percentages can be set to fall within 1.8% of 72%. Write and solve an inequality that represents the percent of users who like changes. So if we want to find the maximum and minimum, x is going to be the maximum and minimum. And if we take the maximum and minimum and subtract 72 from it and find the absolute value, how do I know it would be an absolute value? Because when they're giving you margin of error, that means it can go above and below the percent that they're giving you, which is 72. And this has to be within 1.8%. So 1.8 within means less than or equal to. So this would be my inequality. Now I can simplify this. Since this is less than, I can put the x minus 72 here. When I take it out, it's going to be less than or equal to 1.8, but also greater than or equal to a negative 1.8. Now to solve, I just add 72 to both sides. And I'm left with x is going to be less than or equal to 73.8, but greater than or equal to 72 minus 1.8 would give us 70.2. So it has to be between 70.2 and 73.8. Next, a survey of adults aged 18 to 23 years old by Gallup Incorporated found that 51% live with their parents. The margin of error is 2%. It means 2% above 51 and 2% below 51. Let x be the actual percent. We need to find the range of adults aged 18 to 23 who live with their parents. So the actual percent minus what the survey said, which was 51%, the absolute value of that has to be within 2%. So that would be my inequality. So if I take this out, I would have x minus 51 is less than or equal to 2, but greater than or equal to negative 2. Add 51 to both sides. We end up with 49 is less than or equal to x, which is less than or equal to 53. So the range would have to be between 49 and 53%. So again, if I want to put this in simpler notation, I would have x such that x would be x would be greater than or equal to 49, but less than or equal to 53. Next, so this one is greater than. So greater than means you're going to use the word or. So just think of greater than. So you have or. If I rewrite this, I'm going to have two. When I take this out, I'm going to have two inequalities. So one's going to be, put that over here, 2m minus 9 is greater than 13. So that's the first one. Or on the other side, it would be 2m minus 9 is now less than the negative version. So minus a negative 13. Now I solve, I'm going to add 9, and you get 2m is less than negative 4. Divide by 2, I'm going to have m is less than negative 2. Or on this side, I'm going to add 9 also, and I get 2m is greater than 22. Divide by 2, m would be greater than 11. So m is less than negative 2, or m is greater than 11. So on a number line, I'm going to have negative 2 here, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now you can number those any way you want that. I just counted by ones. So open circle on negative 2, it's less than, so it goes to the left. Open circle on 11, greater than goes to the right. So again, with or, they go pointing away from each other. So this one in graph, again, this is a greater than, so I need to have or here. So if I have 3m plus 12 is greater than or equal to 15, or 3m plus 12 is less than or equal to negative 15. Subtract 12. Now I have 3m is greater than or equal to 3. Divide by 3. M is greater than or equal to 1. Or here, subtract 12. I have 3m is less than or equal to negative 27. Divide by 3. M is less than or equal to negative 9. So on a number line here, I'm going to have My negative is always on the left-hand side. I'm going to have negative 9. I'm going to count by 2, so negative 7, negative 5, negative 3, negative 1, and then 1. I have a filled-in circle at negative 9. It has to be less than, so it goes to the left. Filled-in circle at 1, greater than, goes to the right. Make sure when you do write on your number line, make sure the smaller numbers are to the left and bigger numbers are to the right. Next, check this one. Then we're going to graph it. So this is greater than, so I'm going to have 2. I'm going to put the negative 1 on the left-hand side so it makes it easier when I draw my graph. So I have 4m minus 20 is less than or equal to negative 12, or 4m minus 20 is greater than or equal to 12. So I'm going to add 20, and I have 4m is less than or equal to 8. Divide by 4. I now have m is less than or equal to 2. Or on this side, add 20. I now have 4m is greater than or equal to 32. Divide by 4. I would have m is greater than or equal to 8. On a number line, I'll do 2, 4, 6, 8. We have a filled-in circle on 2. It has to be greater than 2, or less than 2, so it goes to the left. Filled-in circle on 8 has to be greater than that, so it goes to the right. Next one, solve this absolute value inequality with overlapping cases. Okay, so we need to solve this and then graph it. So first we're going to rewrite this with case 1 and case 2. So this is, since this is greater than or equal to negative 5, we're going to put in n minus 6 is greater than or equal to negative, let me put that over on this side. N minus 6 is greater than or equal to negative 5, or n minus 6 is going to be less than or equal to a positive 5. And then solve for these. So I'm going to add 6, and I would have n is greater than or equal to 1. Or here I add 6, I would have n is less than or equal to 11. So on a number line, we'll have 1, and let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 here. We have a filled-in circle on 1 and a filled-in circle on 11. And it says that it has to be greater than negative 1 or less than 11. So that means it goes greater than 1, or it could be less than 11. So you'll see that they overlap each other, but it keeps going in both directions. So now if I put any number in for x, any number for n, so what if I put in negative 5 in for n? Negative 5 minus 11, minus 6 is negative 11. The absolute value of negative 11 is 11. 11 is greater than negative 5. So I can put any number in there and it would work. Because as long as it just has to be greater than a negative number. And any absolute value is always going to be greater than a negative number. So for this one, I could keep my graph looking like this, or we could write it this way. It would be all real numbers. You can just have a thick bar on here, or you can just draw a line in both directions like I had before. But this would be all solutions would work. And our very last one. So this one, We have 2n plus 8 is greater than -5, or 2n plus 8 is less than +5. Solve by subtracting 8. I have 2n is greater than -13. Divide by 2. We would have n is greater than a -6.5. Or here is subtract 8, and we would have 2n is less than -3. Divide by 2. We would have n is less than -1.5. Our number line, we have -6.5, -5.5, -4.5, -3.5, -2.5, and -1.5. We have an open circle at -1.5, and we have an open circle at -6.5. Now it's got to be greater than -6.5, so it's going in this direction. Any number bigger than that would work. And then any number less than here would work. Now because it has to include both, -1.5 is greater than -6.5, so it can equal -1.5 for that one. On the other side, -6.5 is less than -1.5, so that could be one there. I don't need to have the circles here. We just know that it can be in all directions, so it would be all of these numbers, all real numbers. Because again, the absolute value is greater than a negative number. Any number you put in for n is going to give you a solution that's bigger than a negative number. So this would be all real numbers as well. So that is our lesson on solving absolute value inequalities.